so much.
Hello everyone. This is Adithya from India. I am a mechatronics graduate student from Hindustan Institute of Technology and Science, and I welcome you all for the presentation on the engineering facility of Habitat Marte. As a chief of engineering facility, I will be walking you through the habitat design and how it is planned to be constructed. And also we will discuss about few machines and technologies which are necessary for the operation of the installment. And apart from technology, we will also talk about a few management protocols and guidelines that each and every astronaut must follow. And finally, we will be looking at few outcomes of this technology which can be further improved and used during missions in Mars. So welcome to the engineering facility. The main objective of this facility is to carry out engineering experiments and do research for betterment of humankind. So this is a place where innovative, creative, and optimal engineering solutions will be created so that future missions for Mars can be simplified. And also the second objective of this facility is to investigate and analyze the life supporting system and try to increase its efficiency and try to use the in-suit available resources so that there won't be any need for additional goods to be transported from Earth to Mars. So first, let us discuss about the design and construction of this habitat. So this is the design I have made in SolidWorks. This is a 3-layered habitat. As you can see, there are 3 layers. And the top part is supposed to be an closed observatory for research purpose. So this image in your right hand side is a final design of the habitat. And also there is a ladder which goes in between these 3 layers for the astronauts to be able to access each and every floor and layer. So let us discuss about each layer. So the downmost layer is the Rover Bay and Experiment Lab. So this is where the robotic rovers are kept so that it would be easy to take it out of the habitat. And we also have an experimental lab here for astronauts to carry out research and do engineering repairs and everything. The second layer will be of a vertical form, and also dormitories such as bedrooms, kitchen, and washrooms will be placed in the second layer. The third and finalmost layer will be for the computational lab. Since engineering has to do with a lot of simulations, we need a lot of computers and servers, and there is a need for a separate lab for this. And also this layer consists of a few control rooms to handle the observatory, which is above the third layer. So the maximum diameter of this habitat is supposed to be 8 meters, and the maximum height is somewhere around 20 to 25 meters. And this habitat is constructed with an assumption that the maximum number of astronauts will be 6 for this habitat. So this will be the groundmost layer. So this layer will have the entry and exit point of this engineering facility, which will be further connected to a pressurized capsule to maintain the pressure inside the habitat. And this layer consists of a 3D printing facility in the right hand side and a storage or cabinet in the left hand side to store their components and other personal storages. And there are 2 rovers based in left and right of this floor to operate and take the rovers out from the habitat. And at the far side, there is an experimental lab or a repair station, can also be known as repair station. This is where the astronauts carry out engineering experiments, carrying research with electronics and repairs with the life supporting system or rovers. And in the middle, there is a power and control. This is where the power and control system will be installed so that astronauts can regularly check the systems and ensure it's functioning well. So let's come to the second layer. So in the left hand side, there is a vertical farm. So this farm can be used for food production so that astronauts need not to depend on the goods transported from Earth, they can produce their own food. And besides the vertical farm, there is a kitchen, so that it will be easy to transport the food from the vertical farm and prepare their food in the kitchen. And this floor also contains personal dormitories such as washrooms, bedrooms, personal storage, dining area. And this space in the middle can be used for entertainment and discuss area, because astronauts also need to entertain themselves. And this is a place where they can feel relaxed and share their emotions with each other. And this is the third layer of the habitat. So this layer has a 3D printer facility again. There are two 3D printer facilities, one in the ground floor and in the third floor. And again, a storage and cabinet. And this is mission control room. So this is where astronauts communicate with the control in the Earth to report their daily outcomes and everything. And also, I have installed a small gym here because astronauts regularly need to have a healthy physique, and it's their responsibility to do few exercises such as meditation, yoga. So a gym is also necessary for astronauts. And on the right side, there is an observatory control room. So this room can be used to control the observatory, which is above this layer, so that astronauts can analyze the sky and get some data from it and do some data modeling in the computational laboratory, which is at the far side of this layer. So in this computational laboratory, astronauts carry out simulations and play with data. They do data modeling and get some optimal or creative results to further develop products. So this is the assembly of the habitat. So this is the first floor. As I said, this consists of Rover bay and an experimental lab. And this is with the second floor. And this is with the third floor. And you can see there is a ladder which passes through the center of the layers. And this ladder can be used by the astronauts to access each and every layer. And finally, this is the complete design. And above is a small closed laboratory from which they can watch the sky and get some data. So this is all about the internal and external design of the habitat. Now let's discuss about few technologies which are necessary for the habitat to operate. So the first and the most important technology we require is the life supporting system. So these are few things which comes under the system. The first one is generation of oxygen, because we humans can't live with oxygen, and there are numerous ways to extract oxygen from the resources available in Mars, which we will be discussing in the upcoming slides. And the second and most important thing is temperature and pressure. It is very important for the astronauts to maintain the temperature and pressure within the habitat. Of course, this engineering facility will be connected with a pressurized capsule, so that whenever the astronaut enters or exits the habitat, the pressure and temperature is maintained within it. And this habitat must have a very thick shielding to minimize the radiation which is received from the sun. As we know, Mars is having a very thin layer of atmosphere, and there is high chance that astronauts might be exposed to the ultraviolet radiation received from the sun. So there are also few ideas which are currently going on in thickening this shielding of the habitat. And the next more important one is medical care. The astronauts must be trained for emergency medical situations, and must also have the required tools for the medical care. And power and water management are the most important goals of the astronauts they should keep in mind, because it would be very difficult to transport goods back and forth from Mars to Earth. So they have to find few optimal ways to manage both power and water. And the next technology is vertical farm. As I said before, the astronauts has to be independent when it comes to food. So having a vertical farm in their habitat will be easy for them to provide produce their own food and cook it. So I am proposing here a methodology known as evapotranspiration, which 2 years back, myself with my supervisor, we collaborated and reviewed few methods which are being followed to perform evapotranspiration. Let me explain you what is this. So evapotranspiration is actually a process which calculates the loss of water from a plant through two processes. One is evaporation and other one is transpiration. As seen in this figure, E means evaporation and T is transpiration. So these are the only two ways in which water is lost through a plant. So by calculating the amount of water which is lost through this plant, we can compensate the exact amount of water so that water can be managed in a very optimal manner. So this is done through a process known as reference evapotranspiration. So there are numerous methods to calculate this value. There are empirical formulas, and this can also be done through non-conventional methods such as artificial intelligence, neural networks, and so on. Once this reference evapotranspiration is calculated, this value is multiplied with a coefficient known as crop coefficient, which finally gives us the amount of water required for a plant. So this evapotranspiration depends on numerous factors such as the temperature, pressure, humidity, amount of sunlight received by a plant. So obviously there are few sensors which are available to measure these meteorological factors such as temperature and humidity. So installing these sensors in the vertical form and knowing the temperature and humidity and other factors, we will be able to calculate the reference evapotranspiration, and multiplying that with the crop coefficient will give us the exact amount of water required for this plant to grow, so that there won't be any excess of water being wasted, or nor a too less amount of water which is being given to the plant. So the plant receives the optimal amount of water, and I believe through this method, water can be managed and water scarcity problem can be reduced to a considerable extent. And few machines are also necessary to be installed in the habitat. Some of them are 3D printers. When it comes to engineering, and there are numerous electronics which are used, and 3D printers are quite useful because using them, astronauts can print few feasible components within the 3D printing facility. And also, as I said before, there is a computational lab in this habitat. So there is a need for computers and servers for astronauts to carry out the computations and simulations. And metrological instruments such as screw gauges and other instruments are required while dealing with electronics. And electronics and tools, of course, while carrying out repairs and doing experimental research, electronics and various kinds of tools are required. And rovers for assistance to for astronauts, and also for astronauts to travel within a given environment in Mars. And finally, vertical firm, which is also being discussed. And this arrow mark seen here, so this is where our evapotranspiration control system comes. So this evapotranspiration can be fed to a control system which can sense the temperature and humidity and other factors within the habitat and deliver the exact amount of water which is required for this crops. And apart from technological machines, these are few personal necessities for astronauts. As I said before, the astronauts have to keep up their physique. So some gym equipments are necessary for them, and also dormitories such as bedrooms and bathrooms. As you can see, bathrooms in ISS work with the suction technology. And also entertainment and food such as television, radios, and so on. So these are few things which are necessary for astronauts in the engineering facility. So now let's discuss about few possible resources which can be generated in suit in the habitat or in the Mars environment. So the first one is using the subterranean water. Results have confidently proved that Mars contains water in the subterranean. So using this, somehow extracting this water, we can be able to split hydrogen and oxygen. This oxygen can be used for astronauts to breathe, and this the hydrogen can be combined with carbon dioxide, which is available in the atmosphere of Mars. And using the combination of hydrogen and carbon dioxide, astronauts will be able to make methane for rocket fuels. And also we all would be aware of the Mars Oxygen In-Situ Resource Utilization Experiment, which is in short form called as OXY, which is now installed in the Perseverance rover, which converts Mars carbon dioxide into oxygen. So this process actually is carried out through a process known as electrolysis, where carbon dioxide is passed through an electric field, which further divides oxygen, and this oxygen can be used by the astronauts for their survival. And also, uh, as I said before, the atmosphere of Mars is very thin, and it is necessary for the astronauts to have a very thickened shield of their habitat. So using the in-situ water or water extracted from the subterranean, the habitat can be covered with an ice shield, which protects them from intense radiation and a varied temperature of the Mars environment. And also, not all sources can be prepared within the Mars environment. There are a few resources which must be transported from Earth to Mars. For example, solar panels and nuclear power. So solar panels are one of the most convenient way to generate power in the habitat. And nuclear power, for example, the Perseverance rover, which is currently wandering in Mars, has RTG as its power source, which can power the rover for at least 14 years. It has plutonium fuel in it. So using similar nuclear power and solar panels, as well as a few power storage systems, test batteries, we will be able to provide power and make it efficient. And apart from that, we also require experimental equipments and tools for the installation of laboratories, and rovers and smart robots for assistance. As seen in this third picture, these are few kind of smart rovers which might be useful in construction of habitats and other assistance which can be provided to the astronauts. So this is all about the machines and technologies. Now let's discuss about how this habitat is going to be organized and managed. So as I said before, this habitat is constructed based on the assumption that there are 6 astronauts who live within this habitat. So the chief or commander is going to be the supervisor of this facility, and there will be a lead space engineer, an astrobiologist or medical officer, and a lead computational researcher. And under the lead space engineer, there will be a technician for him to assist. And similarly, there should be a data scientist who assists with the lead computational researcher. So the crew commander, the prerequisites for all these profiles are almost same. They all must be a trained astronaut. They must be went through a proper astronaut training and should have excellent management skills, and must be a graduate student from any branch of engineering such as mechanical, electrical, electronic, aeronautical, or computer science, and must definitely have at least 5+ years of work experience. So the duties of crew commander is to the main duty of the crew commander is to maintain the operation of this engineering facility and to prepare briefings and meetings to inform the crew members about their daily activities, and also they should be able to mediate between the team members, and if some miscommunication arises, they must be able to solve the issue, and they are the prime communicator with the mission control center back in our Earth, in our planet. And the lead space engineer, so as the name suggests, is the lead of the engineering facility when it comes to the engineering technology, and he should be able to troubleshoot and repair systems if something goes wrong. And you should also keep in mind about recycle and reliability, and should try to increase its efficiency. The next comes lead computational researcher, and he will be responsible for carrying out simulations and predicting the future effects. And he should also be working on carrying out data analysis, visual analytics, and other computational techniques to solve problems in the habitat, which can further be developed into a product by lead space engineer. So the fourth profile is technician. And this technician should be of assistance to the lead space engineer, where he will lead the project and will be responsible for drawings and other electrical circuits and preparing reports and everything. And it should also provide support and direction during the construction and activation of the power and power distribution equipment. As we seen in the first floor, there is a separate space for power and control. So this technician should be responsible for that and regularly check whether the system is performing fine. The next comes data scientists, and he is a very important person because he is responsible for data collection. For example, collecting data from the observatory and processing it and presenting it in a well-mannered report form. And he should also be able to build predictive models and machine learning algorithms, because rather than depending on computation, conventional computations, it would be easy for one to build a machine learning algorithm as it eases one's process. And the final and one of the most important role is astrobiologists or medical officer. Since we have a vertical form in this habitat, it is important to maintain it because it is one of the main source for the astronauts to have produce their food. So this medical astrobiologist or medical officer should regularly check upon the vertical form and ensure that the evapotranspiration method is working well and the sensors are working fine. And you should also be able to carry out research within the farm and try to increase its efficiency or production. And also, this astronaut must regularly check the astronaut's health and report it to the mission control room. And he will be the secondary communicator within this engineering facility to be able to communicate with the mission control center back in our planet. So these are few training programs which are required for the astronaut to be able to survive in the Martian environment. The first training is technical training, where the astronaut will be trained with the safety and maintenance procedure, how to handle the engineering equipments and other tools. And also he should be familiar with the control system and engineering skills. He should be able to be familiar with basic simulations and other electronic components. And also he should be updated about the experiments which are being carried out within the habitat. And finally, he should be able to use the robotic arm and equipments and rovers which are for assistance for the astronauts. And when it comes to management training, each and every astronaut should definitely have excellent leadership and management skills, and they should be able to cooperate within themselves, should have a spirit of teamwork and be able to adapt themselves to any kind of environment. The third important training is survival training, because there are few uncertainties which might happen, and the astronauts might be well aware of these uncertainties and should be able to manage them. So they must be given basic medical training for medical assistance for fellow astronauts, and they should be updated about the emergency protocols. Like for example, the guidelines one should follow if some kind of breach occurs in a habitat, and you should be well trained with few life survival skills such as camping, swimming, and of course microgravity and buoyancy training is necessary for one to when it comes to space travel. And finally, vehicle training. Since there are more robotic rovers and other smart robots for assistance, the astronaut must be able to manage them. He must be trained with how to drive the rover and how to maintain it. If some kind of problem arises within the rover, how to repair it. And also about the launch vehicle operation and landing and launch procedure and protocols. Since he will be traveling in a launch vehicle from Earth to Mars, he must be trained regarding how to operate these launch vehicle, because it also comes under the engineering technology. So now let's discuss about the resources which one requires for 1 week. So the first and main resource is food and water. So around 500 to 800 grams per astronaut. This accounts to almost 3,200 calories, which is required for an astronaut for 1 day. And water is one of the most important resource, since it is used for various kinds of activities. For example, for drinking and food preparation, and for bath and other purposes, and finally for vertical farm. So at least 2 to 2.5 liters of water per astronaut is required per day. And when it comes to vertical farm, it actually depends upon the size of the farm and the type of crop which is being planted within the farm. And power consumption around 30 to 40 kilowatt. And we have already discussed about few methods to produce power, such as, for example, using solar panels, nuclear power, and so on. And oxygen consumption around 800 to 1000 grams per day. So this oxygen consumption is also being discussed, and there are experiments which is currently being carried out, such as MOXIE and a few in-suit utilization, which can produce oxygen. And this is a basic meal cycle for 1 week, which I have prepared for the astronauts in the engineering facility. These meals have been created keeping in mind the intake of proteins, vitamins, and also few delicious foods. Breakfast mostly includes sandwiches and few vegetables such as cucumber, tomato, and pancakes and cereals. And lunch consists of brown rice, white rice, vegetables, chicken, as they have more protein within them, and or yogurt. And also an astronaut basically requires 4 meals per day: breakfast, lunch, snacks, and dinner. So also after lunch, snacks is also available for astronauts, where they can have tea and other protein shakes, cookies, and healthy soups, and so on. And finally, for the supper, they have few salads and eggs for and proteins for proteins and vitamins. Paneer. So now let's discuss about few protocols which must be followed within the habitat and within the whole station itself. So when it comes to other facilities or the whole station, the astronauts from other facilities must be available 24/7 to support if any problem arises in this engineering facility, and must also ensure a clear and distinct continuous communication among the facilities, because communication is very important and vital. And if any miscommunication arises, it is the responsibility of the commander to resolve it. And also the crew members in all the facilities must follow the protocols and guidelines, and must ensure that the habitat is clean and organized, because there are a lot more delicate electronic products within the habitat, and they must not be exposed to dust or other kind of impurities. And each and every facility must update the outcome for the day or outcome of each experiment to the other facilities, so that they can be aware of what's going on within the whole station. And all the crew members should carefully handle the laboratory equipments and rovers, because rovers are the only source for the astronauts to travel within a given Martian environment. And also the astronauts should regularly do medical checks and practice yoga, meditation, and make a very vital use of gym in order to maintain their physique, and should maintain the integrity of the whole Martian station, and definitely should enjoy their life in Mars. So these are few protocols or routines to be followed within the engineering facility. Each and every astronaut should at least work 8 hours per day and report the outcome of each day to the commander. And it is the commander's responsibility to create briefings or meetings and report the outcome for each and every day to the crew members, what activities are to be carried out for that particular day. And the astronaut responsible for the power and controls must regularly check the life supporting systems and power controls and ensure they're working well and working well. And also it is necessary for the astronauts to wear uniforms while entering the laboratories and performing experiments, because as I said before, the electronic components must not be exposed to impurities or dust. Also, each and every astronaut must record the data which they are collecting each and every day, and the results must be submitted as a weekly report to the commander, which in turn the commander submits it to the mission control in our back in our planet. And also the astrobiologist or the medical officer must regularly check the vertical from and ensure the work function of sensors, because there might be some kind of breach within the habitat, and it is necessary for the sensors to work in a well manner, because sensors are the only source which can sense some kind of breach or some kind of leak, such as ammonia leaks or other kind of leaks within the habitat. So the sensors must be functioning in a well manner. And also the astronauts must try to maximize the use of robotic operations and robotic assistance which are given to them, and try to increase their efficiency. And few protocols of safety. The first and main thing is one should not panic and stay calm, because each and every astronaut has went through the survival training and has been trained for all kinds of emergency situations. So you must not panic and think wisely. And in case some kind of breach occurs within the habitat, one should immediately rush to the place where the spacesuits are placed, and must use them. And also, as I said before, must ensure whether the gas sensors are functioning well, because they are the only source which to sense some kind of leak or breach within the habitat. And must not eat or sleep within the laboratories or control room, because they might damage the equipment or electronics, which might then be difficult for astronauts to carry out their research. And of course, entertainment is one of the major part of their stay within the habitat. One should regularly share their emotions or feeling whenever they feel alone or aloof. And they might watch movies together and listen to music and dance together and lighten up the mood. And they can also play games which are feasible within the habitat, which doesn't include running and what other kind of rough activities. And they must also ensure that they have at least one meal together as a family per day. It can be breakfast, lunch, or dinner, but at least one meal together. And they can also celebrate festivals that are feasible within the habitat, for example, Christmas and other festivals. And can also cook their favorite meal during special occasions or festival using the food which they produce in the vertical form. And the most important thing, must regularly exercise and make a well utilization of gym. And protocols for food microproduction. As I said before, again, gas sensors are very important, because they also are a source to check the quality of air, whether the power controls are working well. And in case of any breach, there must be an alarm which indicates every astronaut to rush up to the place where spacesuits are placed. And as discussed before, water management is very important when it comes to food microproduction. Hence, evapotranspiration technology might be a solution to manage the water consumption. As I said before, there are two types of methods to calculate this evapotranspiration: conventional and non-conventional. So conventional methods depends on a few empirical and semi-empirical formulas, and non-conventional methods relies on algorithms such as artificial neural network, wavelet neural network, regressions, and so on. So this evapotranspiration depends on various parameters, like we discussed before. It depends on humidity, temperature, solar radiation, wind speed, and so on. You can refer this paper for more detailed review on evapotranspiration and how it can be able to solve the water scarcity problem when it comes to food or crop production. So let's discuss about the outcomes of these technologies and some of them which can be applied in our planet. So first thing, again, as I said before, water management and evapotranspiration technology. So this is a small conclusion from our review, where we mentioned that these technologies can be applied in a real-time situation by developing an optimal water usage control system, which can later be used by farmers to estimate water required for crops. Also, the 3D printed shelters. Also, the 3D printed shelters can be built in our planet rather than depending on trees, thus saving them and decreasing the amount of deforestation which is being happening. And also, we could try to increase the efficiency of future robotic rovers and research. And energy and power consumption are the two main lessons which astronauts learn by living in other planets. And this lesson can also be taught to our people in Earth, and they can try to reduce or minimize the consumption of energy and power and try to use it in a very optimal way. And also, reusability and reliability are way more important for people in our Earth. This can also be a lesson from living in another planet. So finally, let's see what are the impacts on sustainable development goals. The first one is decent work and economic growth. As I said before, we are trying to maximize the usage of natural resources such as solar panel and so on, thus minimizing our dependencies on non-renewable resources. Hence, the amount spent on these non-renewable resources such as fuels, petrol or diesel can be reduced, which can contribute a lot to our economy. And also industry innovation and infrastructure, improved efficiency in construction and advancement of technology. The research which will be carried out in Martian environment will open up more insights about our engineering technology and might give a lot more innovative and optimal solutions. Sustainable cities and communities. So we must ensure that the social, economic, and environmental impact which we are currently enjoying must also be available for the future generation. And responsible consumption, optimally utilize the available resources and maximize the output. Like I said before, water and power management. When it comes to optimally using them, a lot more energy can be saved, which can be used further for our future generation people. Affordable and clean energy. So maximizing our dependencies upon renewable resources are such as solar, wind, and other thermal resources are considerably very cheap and clean when compared to non-renewable resources. And finally, partnership for the goals, together promoting the mankind to provide a safe and friendly planet for our future generation. So these are few references which I have taken to prepare this presentation. And I thank for your patience to listen this presentation. And if you would like to connect with me, feel free to drop me a mail in my email, or you can also have a look at my LinkedIn account, or can also contact me regarding any doubts regarding this presentation. Thank you.